Good morning, everyone. Welcome to the last session of the morning of the last day of DevDays. So it's my pleasure to introduce Christiaan, who will present how microservices could help to face some of the challenges for the scaling and maybe versioning for FHIR server. Christiaan, the floor is yours.
Thank you very much, Louis. First of all, I understand I'm between you and lunch, so we'll make this quick. And scaling FHIR with microservices, we've been experimenting with that for FHIR server at FHIR. And I just want to share some experiences. It's not the way to do it. Hopefully, you can just learn something from it. I am Christiaan Knaap. I'm the head of product at FHIR and also the architect of FHIR server, which is slightly more relevant in this case. And of course, we make a couple of other very interesting products that you get to check out later. My life for the past 2 weeks was about heat pumps. So this is the monolith heat pump, and it works very well. But if you want more or smaller, or you just a smaller one or more. But I live on a houseboat, and then things get different. So this was our garden. But it has its advantages, because if you want more tap water, you get a bigger boiler, or a bigger pump, if you have large floor to heat, which we don't. And if you want to get more heat out of the water, you just get bigger sources. So I thought that aligns very well, until the plumbing. So installation took like 7 days instead of just 1. So that kind of sums up the idea of microservices. You are a lot more flexible, but you need to do a lot more as well. I hope you learned from this that you can make a slightly better judgment on whether or not to use microservices for yourself. So we'll start where we were shortly before the origin. I am a mathematician from nature. Then we'll do our first getting our toes dipped into the water with the validation module as a Lambda. Then next on, we go to our microservices proof of concept for our sidecar architecture, and we'll wrap up with some lessons learned. So where are we now? This is FHIR server as it is now. It's a pipeline of modules. You can just turn the modules on and off as you see fit, but it's all in one executable. It's .NET Core. And you can choose your own, you can choose your database. You can run it on SQL Server, Mongo, SQLite, or implement these data access interfaces that you see below on your own database, which gets you a facade solution. And having a monolith architecture is quite common, actually, because Happy in Basic is a monolith. Linux for Health is as well, as far as I can see, the Microsoft FHIR server 8-box. And there is even a page on service-oriented architectures in the spec, and it has a maturity level of 2. So I think even GraphQL passed that, I don't know. Running a monolith still involves several services because it doesn't run alone. You can scale it out, and you need all the integrated logging and monitoring as well still. So there's a bit of experience already, of course. Now, on to the validation service. We had a customer, he said, yeah, your validation engine is great. It's fast, it's complete. But can we run it as a Lambda on AWS? Well, it was in our server. That was a bit hard. But it was an interesting challenge. Also, the validation server is resource intensive. It needs structure definitions, terminology, and then run through the whole resource to see whether it's valid. So it might be useful to scale it out individually, separately of the server. And we want to apply it in several places. When you post a resource, is it valid? Otherwise, we just don't accept it. In the data pipeline, I will show that. Or maybe you already have a bunch of resources, have a new profile. Which of the resources is valid against that new profile? So we learned a couple of things already from that. So typically, here is a validation in a data pipeline. This is how customers now tend to load their server, who has attended Frank's talk on Tuesday, because he showed 2 of our customers who are actually doing exactly this. So there's queuing in the middle, and it eventually ends up in a bulk ingestion tool. But on the way in, they want to be able to validate their stuff. That means it needs to be able to scale. And you need, if you actually want to run it as a Lambda, you want fast startup. And FHIR server starts up pretty quickly, but not fast. It's a server. First of all, so what do you send in to validate? We had to think about that. It's not an HTTP message. We want it more simple, but it needs to have the essential things. First of all, a message schema version. We started with that right away. We had some experience. So you don't do that as an afterthought, because you can never version your first version again. We always provide a message ID to trace it along the whole thing. And if necessary, you can have linked message ID. So if it comes, it's produced based on another message that can be recorded. Easy for observability, for tracing. And there's a single resource in it. Can also be a list of resources if you want to do things in parallel. And we add the metadata outside of the resource. It's the same data as the resource, but as you may have found, if you implement things yourself, the resource type could be at the far end of the resource, especially in JSON, which is not very practical. You have to parse it completely before you know what it is. So we take that out. Also, the profile is useful to know, especially for validation. And there can be security labels and tags who could, for instance, denote a tenant or some authorization information. And lastly, there's variables. I'll come back to that as well. We do that for service testing. So it allows us to trigger chaos, trigger slow responses, trigger timeouts based on a distribution or an error response. So you know that your service will also behave if that happens. Then about the fast startup. Validation server needs a lot of conformance data, not all of this. But this is kind of the list of conformance data that you have in FHIR. I probably missed a few. Very stable at the top are the core structure definitions. And then you have compartment definitions. They are defined by the spec. You're not allowed to define any else. And there's the simple FHIR code systems for gender, for other stuff. There's the search parameters, not needed for validation, but we'll need those later on. Profiles are a bit more volatile already. If you have a fixed package like US Core, it's stable. Currently, FHIR server allows you to just upload any profile, and you can use it. So that's more volatile already. And then there's the more complex code system. I just learned from the SNOMED session on the first day that they add 800 terms every day or so. So that is volatile. And then there's things like subscription topics and with definitions, activity definitions, questionnaires. So that's even more volatile. So what we did is the things that are stable or relatively stable, we move that from the runtime, our administration API, where you can just upload and change things, to build time. We take a FHIR package and all its dependencies, so all the profiles, also the search parameters, but also the code systems. We expand all the value sets up front. We generate a schema out of the structure definition that aligns very well with our validation engine. It's a bit like the JSON schema that was discussed in the Birds of a Feather, I believe, yesterday. We parse all the search parameters to see whether the expressions are valid, etc. It's a lot of work, and we see the structure definitions, all the dependencies match up. We generate snapshots, everything, and that is a lot of work. So we do that upfront, and then afterwards we have kind of a compiled package that allows us to start up in under milliseconds. Actually, we found out that starting a Lambda takes a lot more time. So We outran that. It does mean that you cannot just change the contents. If you are in a development phase, that's annoying. But once you go to a production server, probably that is a feature. So here's the list. So we do strong consistency testing. And so at deployment, it's stable and predictable. And that's what we like. The really large value sets, the SNOMED, the LOINCs, cannot be catered for in this format. So you need to be able to reach out to that and cache the results if you want to be fast. And it does mean you cannot write the conformance resources while it's running. What does the service look like? It has an API that can cater for request reply messages. So is this valid, yes or no? And then I can either continue or not. So that's for writing data. But we also have it in a pass-through mode or not pass-through. And if it's invalid, like in the situation of our Dutch customers, we just pass it on to the dead letter queue for inspection later on. This was not valid. We're not going to process it any further. Now we needed not just one log file from FHIR server, because now certainly some different components start producing logs. So we integrated that neatly in our case by default in Seek, or any tool that the customer prefers. It allows for structured logging and connecting all the dots with that message ID. So that worked as a Lambda. Then we go on to some more microservices. Because we like this. And we can have more of that. But you don't just do it because of all the consequences. So why would we do this? First, we created this picture. There's a lot on it. So it's all kinds of things that FHIR can do that you might consider doing separately. Or not. So we considered this picture and said, which of these would be interesting to do separately? And it led us to the conclusion that there's several pieces of FHIR. So there's different domains. I didn't show that, but you can show that in the opening page of the spec. You already see all the domains: administrative, financial, etc. All the FHIR capabilities from the previous thing, different use cases. Different tenants maybe, different periods once you start and you need to load everything, or once you're in production already for a year and there's slow updates, or many reads. So all of these aspects on the rest and on the right, and I probably forgot some, can vary. Data size is being stored, data size that you need to process. Response time may be critical or less critical based on the use case. The load may vary. At first you have a huge load of writes, and then afterwards a huge load of reads, hopefully, so people are actually using it. But also the maintainer could vary. In our case, we allow plugins, and we allow people to build a facade. So part of the code that's being run is not maintained by us, but by the customer. Also, the maturity of some aspects can vary. Authorization, complexity, and of course the optimal tech stack. Some things are just better done in other tech stacks, or already done in a different tech stack. I tend to think .NET is best for everything, but I know it's not the case. And then we combine that with some custom requirements. We see customers that are running their own EHR, for example, and they suddenly need to comply with G10, for example. So we want to solve that for them without interrupting their workflow too much, or their process. And then allow for innovation at FHIR speed. Most EHRs tend to have difficulty to innovate their product. It's been stable for 20 years. Don't change things that are not broken. So now we wanted to allow them to innovate at the side. Avoid data duplication. You've all come in through Schiphol. There's not enough power anymore to add any data warehouses. So we should limit the duplication. So we make the facade implementation even easier to accommodate that. And then scale these FHIR capabilities on that, in that diagram independently. So you can disable what you don't need, where the customer said, yeah, we have an appointment application. I don't care about all the old slots, but you generate history and history and history of it. How do I get rid of it? Well, we just should not do that then. Scale operator was heavily needed. Search is generally heavily needed, but if you suddenly have a bulk data request from the B10 requirement, for example, saying someone wants a system export, you better scale that out. And optimize storage. Audit events, hardly ever you looked at, but there are many. Binary, large files, you need something else for that. And we want to allow for customization in other tech stacks. Because also not all our customers prefer .NET Core. Many do. So we decided to own a proof of concept, and we thought, let's start with the hardest part, which is the core services. It's storing the resources and indexing them for FHIR search. As currently the history is also integrated, that needs to be split as well. And then connect them through messaging instead of just internal memory calls. And thereby facilitate a side-by-side architecture and individual scaling of the several components. And then to allow for that facade implementation, we want the customer to be able to implement that resource store. And we asked ourselves a few questions. If we do that, what infrastructure would we need to host this? So we set a performance target, more than just this also on the read side, but that's, I'll spare you the details. If we want to do this, how much infrastructure do we then need? And then probably we can calculate the rest. Can we indeed scale these services out independently, or is it too much coherence or to do that? Can we make the facade interfaces simpler? Currently, you also have to map search parameters, and that's the hard part, so we want to avoid that. And can we still implement FHIR transactions? Because if you start splitting things, who has ever tried to implement FHIR transactions on the server side? No? Lucky you. This is in a picture where we wanted to go. We see I highlighted the store, which has a client that accepts messages, either as a stream or in a request-reply fashion, same message. And at the bottom it has a change stream, so it reports everything that changed in the store. Every resource that was created, updated, or deleted is then posted to a queue, and then off of that we feed all the other services. And then here on the far right to you, there is of course still the FHIR REST gateway, which still looks pretty much the same as the current architecture does. From here, it gets interesting, because now we can start moving these two interfaces. Because for a side-by-side implementation, we say, oh, but what if we let the customer also implement the change stream and feed our store with it? Well, we just put a line in between and say, do whatever you want, and we do what we want. Just send us the updates. Of course, there is always, very importantly, a transformation. Customers tend not to store their data in FHIR. If they already do, they probably don't need another FHIR server. Also, here from our change stream, you can feed your own components, for example, for analytics. Restructure it again into flat tables for your use cases. There were a couple of sessions on that as well. Databricks on the first day, and a session by Nikolai on SQL on FHIR, and they all tend to go use case based. So that's interesting if you can add your own components to that for each use case, or covering a couple of use cases. And if it's async, it's no problem generally. And now we can move a couple of other interfaces to make a facade. We say, well, no store here anymore. Avoid the data duplication. You just store your own resources and implement that store client to accept writes. And still publish the change stream that we now directly connect to all the other components. So now we have a search index to the side, just like you would have an elastic index. For the proof of concept, we decided not to do all these services, of course, but the really hard part, which is indexing and then searching through the index. They are connected through their database. It's logically one service, but practically different. Implement that store ourselves, and then do a little bit of the transaction to see whether you can actually manage that. So how could we make that message? So the message going here should be so simple that we can actually implement it, which means it should be rather simple, and our customers can implement that. So we created this. It's a bit like a bundle, but then much simpler. So you recognize from the the simplest thing is the store plan, and it has instructions for every resource. It has an item ID, so you can report on that same item. It has an operation. We first thought, well, upsert and delete is enough, but then again, create and update aligns better with a FHIR specification and also allows for easier integration with history afterwards, so you know what actually happened. So we added that as well. Again, we extracted the resource type and the resource IDs. You don't have to read all through the resource to find that out. And of course, include the resource itself. It's that simple, and just we result only the errors. So everything that's not reported is correct. You also need to be able to read the resources back out of the store. And it's pretty much the same thing. We give you instructions on which resource do we need, either only the latest or a specific version. Specific version is interesting if you want to do some concurrency checks. And whether you know whether your search index was up to date, for example, or it's already superseded by a new one. And the result is kind of predictable. So 200 for the first one and 404 for the next one, because that failed in the store message, if you had seen that. Now we needed to connect all the thing with messaging. We started off with RabbitMQ. We already had a bit of experience at our customers, and that worked well. It was a challenge to get that up to speed, but it was more learning to know the tool, learning how to interface with it. So we moved around, we tried Kafka, seeing why is this not performing very well? But that took a lot more time to set up and manage. We tried Azure Service Bus. Then you hit the limits of message size, unless you go to a much higher tier. And then we went back to RabbitMQ, found out that what really helps is micro-batching and not acknowledging every message individually. The mass transit library is a .NET library allowing to address these three message queues. And you can just switch it with configuration, so that is very helpful for us, or for people who actually have a higher tier on Azure Service Bus and want to run their messages over that. It also allows for sagas and all kinds of complex stuff. It can let you switch between these request to reply messages and streaming messages, so just notification. So that's very helpful. But you need to learn the tool, because it's kind of documented. To reach this performance, we needed only a modest cluster of 4 nodes. That ran as well RabbitMQ and our own services and everything, but we did put the MongoDB database on Atlas. We tried this first on MongoDB. So Atlas is the cloud offering of MongoDB. So we let that scale for us. But then it turned out that the scaling indeed worked, because we just ran one store, because that was really easy. We fed the resource in JSON. It just stores as a JSON. That's what Mongo is good for. But then we needed 7 indexers to keep up with that. And we could just scale it until the queues were stable. And then it worked. Now it's up to us, of course, to make the indexing faster, so we need only 3. But it worked, and that was a very good result. There is a bottleneck, though, and that's from the change stream from the database, you need to publish messages about the changes. There is a single change stream and a single consumer of that, so that's a bottleneck, and you cannot really scale it out. So what we chose to do is just grab from the database what you need and then push it into a message queue again to do whatever you need to do afterwards, because then you can scale out with competing consumers. Typically, you need to transform it to some other format again, and then it's very, so first put it in a queue and then scale out. Or somehow partition the change stream or the whole database, but that's a different topic. Let's see, okay. So then we tried transactions. And we found out, luckily we had already implemented transactions years ago, so we knew a lot about it. And we found it can be done to first resolve all the conditionals using the search. First assign IDs. That means that if you run a facade and the database is very picky about its IDs, you need a service that can assign those upfront. So it's not like, for those who have SQL Server, do not use identity, use sequences, so you can reserve them upfront. Because you need them to solve circular references. Otherwise, if you get them afterwards, that's very hard. We can check the authorization, whether you are actually allowed to write things using Smart and FHIR, and then derive that store plan, that very simple message that I showed earlier, that just says create this and update that. Done. And then we send it off to the store. How do we get there? Because as you may have seen from the previous, I didn't show everything here, but doesn't matter. This is basically our current architecture, and that's different from what we where we want to go. But the nice thing is we can move these interfaces to our current architecture as well. So we implemented the store client on top of our own data access interfaces, and now it behaves as a store, and we can let the EHR publish its changes directly to it. And we also tap our own change stream to allow you to add your own services after the message queue. So that's how we can achieve the side-by-side thing already now. And we kind of treat our own server as a facade. So that was kind of funny. Check. So what we learned is that you do need some serious plumbing. On the top right, you see starting filing server in a command line, and it's done. It runs. You get a log. But then once you go to the services, we have Seek, we have the transaction service, the gateway, which is the REST part, Mongo running. This is locally. We have RabbitMQ running, we have search running, we have the indexer running a couple of times usually, we have the store runner, and we have the publisher running, and then we don't even have all the other services yet. And all these need to be in the right order, you need to log it, etc. Well, whoever has done any Kubernetes before and Helm, you better learn that. So all the developers at least have to have a bit of a grasp of what happens here, and also be able to adjust it, because when you're developing a new service, you need to be able to adjust all these deployment schemas. Observability is a whole topic on its own, because there's so many tools to actually do that. There's Prometheus and Grafana and Loki, but it's lots. So that's a world on its own, and you need people to manage that and advise the rest of the team. The debug experience is less. Within a service, it's nice. Across services, less. And you need to take into account the communication overhead, which is why we set those performance targets up front to see whether you could actually meet that. We also identified a couple of challenges that we still need to face, and that is search is used just about everywhere. So the smart scopes in the version 2 can be expressed as in search parameters, and we support smart version 2. And that in turn affects the search itself, but also bulk data export, which could be limited by these scopes. It could limit the dollar everything. It could limit what you can do in a transaction, in subscriptions even. So we need to see whether we can actually separate that or evaluate search parameters in different places. They even come as compartment definition links. Those are also search parameters, reference search parameters. So that's a challenge we still have to face. Confident that we'll solve it, of course, but and then we need if it gets really time critical, Vivian pointed that out yesterday in the Google talk, that you might need reconciliation if you have very updates that come after each other really quickly on the same resource. Now, luckily, we now have an architecture that can host other technologies, and Google solved it for us, so thank you. And of course, we have to pull off the full migration to this new architecture. But we see a way forward as in the previous picture. But what we learned is in general positive. It is a viable approach. It adds to developer happiness, because we regularly have new developers coming in on the server, and then it's huge. First you need to learn FHIR, and then you need to learn the server. And then after a couple of months, you start being productive. Whereas if we now can say, well, this is what this service needs to do, make it do that as fast as possible. That's a lot more rewarding, and you see quicker results. As I already said, you have to train your team on a couple of other things. And designing the message, and all, especially the intent of the message, and the expected results takes time. We went over it in a couple of iterations, and now we are making the documentation for the implementation of the one that you saw on the migration slide. So now it gets final, and people get to implement it, and then we cannot really change it easily anymore. Any questions? Hello? Maybe that mic can be turned on. Thank you very much.
Not yet?
Yep.
Yes. So thank you, Christiaan. So as already suggested, if anyone has a question or comments or
maybe on this side behind the monitor. Yes, Vadim.
Do you still have strong consistency in the new microservices architecture? So if I send in a batch with a create and a read straight away of that resource, will it work?
Well, that's the interesting thing. The specification says about transaction that no two items can address the same ID.
A batch, not a transaction.
A batch need not be consistent, I think.
No, as in after the
for a
create
read,
request is completed, can you read it back straight away?
Read, yes.
Indexing,
Search,
validation,
no.
Everything done by then.
Yeah.
By the end of a request.
So the answer is read, yes. Search, no. Search will be eventually consistent.
Okay. And validation?
And validation, if you do that, depends on where you do that in the pipeline. Yes, but if you run a transaction, it will be validated before it hits the store, so that will be consistent. We offload everything from the store. If it gets something, it's ready and valid. Yep.
We have another question here.
Thanks for the talk. This POC is going to be productized. how are the deployments? Is it single tenant, multi-tenant? And if it's multi-tenant, how do you prevent starvation by one customer over the messages that are coming from the other? And how do you do, let's say, billing around the use of your complete infrastructure?
Yeah, one thing, we take this opportunity to integrate multi-tenancy as a first-class citizen. So we take the tenant into the message. I didn't elaborate on that here as well. So every user can have every tenant can have its own database. Are you referring to how we would build different tenants or how our customer would build their tenants? Because on the first, we don't host our solution ourselves. We make our customers host it. I have no clear answers yet on how you would transfer that to your billing for different customers. But many of our customers tend to have a deployment per customer anyway, so then it's less of a problem.
Exactly. If it's a single tenant or single customer deployment, it would be all the cost, it's yours.
Yeah.
But do you have some functionality already or foreseen, or are you going to look into it? Like if it's a multi-tenant instance, you want to have some transactions or the messages that are passing through, whether it's 100,000 or 100 million messages for a particular customer on the same infrastructure. You have to have some kind of a division of the cost over your whole deployment.
Yeah, no, we have not thought that out yet, but it's a very good addition. And since these messages are passing along anyway, it would be relatively easy to tap them or inspect them and collect the metrics on that.
Thank you.
I think there were no good other question. No, okay. So there were also a comment on Wover regarding open telemetry. It was.
So what is the question?
It was. I think it was more common, like if, because I think you noticed the correlation ID, and it was kind of common. Why not use open telemetry?
We do use open telemetry. That still leaves a whole world open on how you then consume the data from that open telemetry, of course. But luckily for us, .NET Core is standardized on open telemetry nowadays, so that is relatively easy for us to use.
Okay.
Yeah.
So I think we can close the session. Check last time on Wover, no more questions. So thank you again, Christiaan.
Yeah, you're welcome. Thank you for listening in. If you want to ask anything afterwards, you can do that here.
And please submit also your feedback on the link.
Oh yeah, please give feedback. So if you don't want to see me anymore here next year, give feedback. If you do want to see me, that's also fine.